Hey you guys, this is Snowy88 with another nice video, this time about something astronomical. And I want to talk about what you are seeing right now. And most of you would recognize this because this is M31, also known as the Andromeda Galaxy. And I think a lot of people have a misconception about what they are seeing here. I have downloaded this picture, and as you can see, it's a very large picture. This is a very long exposure from the Hubble Space Telescope, and I can zoom in very far into this picture. But first of all, I want to give you an idea of the size of this thing. The size of the Andromeda Galaxy is about 220,000 light years from this end to this end. Okay, 220,000 light years. So let's pick this file I made in which I explain something about what is a light year. Now most of you do know what a light year is, but for all you guys who don't know what a light year is, 1 light year is the distance light travels in an entire year. So imagine if light is traveling at 300,000 kilometers per second, it can travel around the Earth 7 times in 1 second and go to the moon in something more than a second. So you can imagine how far it will go in an entire year. It will travel a distance of approximately 9.5 billion kilometers in 1 year. So a light year is not only a term which is used for distance, but also for scale. So if we say the Andromeda Galaxy is 220,000 light years, which I pointed out here, and we figure out the math, then we come to this conclusion that the Andromeda Galaxy is 2081 quadrillion kilometers in size. And have to note that a quadrillion is a 10 with 15 zeros behind it. So take a walk. That's a very big distance. Okay, so that's a very big distance. So what can I say more about this picture? Most people think that the white dots they see are within this galaxy, all these other dots here. But the fact is, most of all these dots, and now I will zoom in a bit. Let's take, for example, this dot, this dot, this dot, this one, and all these other white dots. They are not part of the Andromeda Galaxy. They are all foreground stars in our own galaxy, because we are inside our galaxy watching to this galaxy, and we have to peer through our own galaxy to see this one. And there are a lot of other stars in the way, and those stars are in this picture as well. Now you might say, why does these stars are also foreground stars, but they have spikes? Why do they have spikes? That's because they are closer by. So this one, this is a blue star in the foreground. This is a red star in the foreground, another red star in the foreground. This is a red star in the foreground, this one too. And let's see, do we have something more? It's a big picture, so it scrolls a little bit. No, well, yes, here we have another one, and here a spiky one, and here one as well. Okay, but all the other round dots are mostly foreground stars. In some other pictures you might see a background galaxy, but in this picture I cannot see anything. But background galaxies tend to be more oval in shape. So in this picture there are two exceptions, and you might notice them. That's this blob over here and this smudge over here. This thing is called M32. It's a dwarf galaxy, which is a companion of M31. This tiny ball contains millions and millions and millions of stars, but they are too faint to be resolvable. This oval-shaped thing is called NGC 205, and it's an elliptical galaxy as well, although it's a bit more elliptical, while M32 is more roundish. This one is also a satellite galaxy of the Andromeda Galaxy. Now, what can we tell more about this galaxy? Well, this galaxy is about, well, it's 220,000 light years in size. Our Milky Way is about, well, it depends on what is actually known about the Milky Way, because there have been recent discoveries about our own Milky Way being corrugated and giving it the upper limit of 180,000 kilometers. I'm sorry, 180,000 light years. So if our Milky Way should have been on top of this, it would span about, let's say, 210, about maybe until here. And that's a very thin line. Let's make it a bit thicker. Probably about until here. Still a thin line, but you get the picture. That would be the maximum size of our galaxy. Alright. Now, what can we say more? Let's zoom in. I want to show you something. Oh. Like I said, because the picture is very big, it's very hard to zoom in. As you might notice, the central region of the galaxy is yellowish and the outer rim is bluish. Okay, now I will zoom in again. So, come on, okay. Okay. You see these blue dots? These blue dots? You might think they are stars, but they are not. These blue dots, like this one, for example, are actually star clusters. It is very well possible that this tiny blue blob is a collection of 1,000 blue stars, which are comparable to this one. This is a picture of the Pleiades star cluster M45. Now, this star cluster only contains, well, 7 known stars, but there are more anyway. But all these stars are individually much bigger than our own sun. So if you look at our galaxy from the Andromeda Galaxy, you would see this star cluster the same way, like maybe only this tiny little blob over here. You would not even see our sun in this picture. I can zoom in whatever I want, but as you see, the resolving power of the Hubble Space Telescope is limited, so in this picture, no, you cannot determine a star like our Sun. So this gives you an impression of the size of this galaxy. So I hope you learned something now about how these things work, and that all the white dots, most of these white dots, are foreground stars. This is a satellite galaxy, this is a satellite galaxy, and these dark bands you see here, those are clouds of gas. They are so dense that they obscure the light behind it. And here is another one, although you might think it's just something you can peer through, but it's there. And here is another one as well. Another fun fact is there is some debate about the mass of this galaxy compared to our own galaxy, and the point is even astronomers are not sure about it, because it depends on how much dark matter is available in this galaxy. As far as they have determined now is that our galaxy, the Milky Way, is 10 times as denser as this galaxy. And there's a reason for that, because if you Google for M31, let me see images, and let's see, no, in infrared, yes, here we got it, this one, here it comes. Look at the structure of this galaxy. Do you notice something very peculiar about it? This galaxy looks more like a ring galaxy than an actual spiral galaxy. So there is a lot of empty space here, here, and here, and here a bit as well, while our own Milky Way is much more compactor. So about the mass, they probably are about equal in mass. The Milky Way also produces 10 times as much more stars than Andromeda Galaxy, but on the other hand, the Andromeda Galaxy has a far more heavier central black hole than the Milky Way. So, well, they have not quite figured it out yet how much mass there actually is in both galaxies. There's also the matter of the halo, and to point out what a halo is, I will show you. M31 halo. Let me see, a halo is something which surrounds the galaxy, and there are not, well, maybe, well, you must see it like this. This is the entire galaxy, and a halo is a structure around the galaxy which consists of much lesser stars and is nearly invisible, but it is there. But both the galaxy Andromeda as our own galaxy do have a halo, so even that not certain yet. So that is my story about the Andromeda Galaxy and about its size, and think about it. It's quite insane, it's quite interesting stuff. I recommend you to visit the Wikipedia site about it. You go to wikipedia.org and just type in M31, and it, oh, this is Dutch, you don't want Dutch, English, M31, this one, and you can read all the information about the Andromeda Galaxy, and also it says here it's 220,000 light years in size. So thank you for watching, and until the next time, See you guys. Bye bye.